Hi everybody, my name is Rishi and today we will be learning about limits in mathematics. So what are limits? Limits are values that a function approaches as the variable in the function. For example, x in the function f of x gets closer and closer to a particular value. The phrase what value does f of x approach as x approaches n is typically represented by the notation on the slide. Now moving on to continuous and discontinuous functions. A function f of x is considered continuous at a value a only if it satisfies the following conditions. 1. The function exists at a. 2. The limit of the function exists at a. And 3. The function is equal to the limit of the function at a. A discontinuous function is a function that does not satisfy one or more of these conditions. Moving on to left hand and right hand limits. When the value of x gradually increases as it gets closer to the required value, it is called a left-hand limit. This is represented by a small minus sign. When the value of x gradually decreases as it gets closer to the required value, it is called a right-hand limit. This is represented by a small plus sign. If the left-hand limit and the right-hand limit of a function are not equal at a point, then the limit does not exist. So what exactly do these limits mean? As we can see for the graph of x square, as the values of x increase and get closer to 2, the values of f of x approaches 4. And so we can conclude that the left-hand limit of the function x square as x approaches 2 is 4. Similarly, as the values of x decrease and get closer to 2, the values of f of x approach 4. So we can conclude that the right-hand limit of the function x square as x approaches 2 is also 4. This also tells us that the function is continuous. Now on to some basic rules about limits. The constant rule. The limit of a function multiplied by a constant k is equal to k multiplied by the limit of the function. The addition rule. The limit of the sum of two functions is equal to the sum of the individual limits of each function. The product rule. The limit of the product of two functions is equal to the product of the individual limits of each function. The power rule. If the limit of a function as x tends to n is equal to some real L, then the limit of a function to the power a by b is also equal to L to the power a by b. Naturally, all these properties hold for x tends to c, where c is a real number. So for limits being infinity, let's take a look at the function 1 by x. As we take smaller and smaller negative values of x closer to 0, the value of the function becomes a very large negative number. So we can conclude that the left-hand limit of 1 by x as x tends to 0 is negative infinity. Similarly, when we take smaller and smaller positive values of x, the value of the function becomes very large, but it's positive. So we can conclude that the right-hand limit of the function 1 by x as x tends to 0 is positive infinity. However, the limit will not exist at x is equal to 0, as the right-hand and left-hand limits are not equal. As for limits where the limit is 0, let's take a look at the function 1 by x once again. As we take larger and larger values of x, the value of the function approaches 0. So we can conclude that the limit of the function as x approaches infinity is 0. Similarly, if we have a function k by x to the power n, where k and n are constants and n is positive, the limit of the function as x approaches infinity is also 0. However, both of these functions are not defined at x is equal to 0, so the limit does not exist at that point. When an expression is made up of a polynomial divided by another polynomial, divide the numerator and denominator by the largest power of x in the expression. If the highest power of x in the numerator is larger, then the limit as x approaches infinity is infinity. If the highest power of x in a rational expression is in the denominator, then the limit as x approaches infinity is 0. If the highest power of both the numerator and denominator are equal, then as x approaches infinity, the limit is equal to the ratio of the coefficients of the highest powers of x on the numerator and denominator. So what exactly does this mean? Let's look at the function x cubed plus 4x squared divided by x squared plus 1. So the highest power of x is 3. So we divide both the numerator and denominator by x cubed. We can then see that the numerator has the highest power of x now, 0. Therefore, we can conclude that the limit of the function as x approaches infinity is infinity. We can take the function x squared plus 2x divided by x cubed plus x, where the highest power of x in the expression is still x cubed. After dividing the numerator and denominator by x cubed, we can see that the highest power of x in this expression is in the denominator, 0. So we can conclude that the limit of the function as x approaches infinity is 0. Now let's take a look at the third case, where both the numerator and denominator have the highest power of x, 3. So we again divide the numerator and denominator by x cubed. So we have the highest power of x now, x to the power 0, in both the denominator and the numerator. So we can take the coefficients of x to the power 0 and divide the coefficient of the numerator by the coefficient of the denominator, and that is our limit. So the limit of this function as x approaches infinity is 3 by 2. To find the limit of a surd, rationalize it with its conjugate pair. Let's take the function square root of 1 plus x minus square root of 1 minus x divided by x. By multiplying the numerator and denominator by the conjugate pair of the numerator, we eventually get the simplified expression to be 1. And the limit of 1 as x tends to 0 is 1. Therefore, the limit of the function is equal to 1. Now let's talk about the limits of trigonometric functions. The limit of sin x as x tends to 0 is 0. The limit of sin x by x as x tends to 0 is 1, which can be proven by the squeeze theorem. The limit of sin ax by x as x tends to 0 is a. The limit of sin ax by sin bx as x tends to 0 is a by b. The limit of tan x as x tends to 0 is 0. And the limit of cos x as x tends to 0 is 1. These limits will help us in the next video when we will explore differentiation using limits. Well, that's all for now. If you enjoyed the video, please make sure to give it a like and don't forget to subscribe. We will see you guys later.